Hello everybody, welcome back to chemistry. We're still talking about acids and bases, and this time we're going to be looking into the three different scientists or groups of scientists and how they define what an acid and base is. Last time we looked at, okay, what are acid and base indicators? I said that acids start with H's and bases have hydroxides or give up hydroxides. That was a loose definition. Now we're going to go into the actual official definitions of what acids and bases are. But for a quick review, acids will turn litmus papers red and bases will turn litmus papers blue. Okay, now that's whether we have red litmus paper, blue litmus paper, purple litmus paper. If you see a color change, red change usually means acid, blue change usually means base. And we talked about phenolphthalein, which is a clear acid-base indicator, and that one turns hot pink in the presence of hydroxides, the base. And I also said that another term for base is alkaline, alkalinity. Okay, so if you hear the word alkaline, just know we're talking about bases. Today we're going to talk about Arrhenius and his definition of what an acid and base is. And his definition is probably the simplest out of the most, and the definition that we'll probably use the most also. So let's take a look here. Arrhenius says that an acid, look right here, an acid is any substance that when mixes with water will put hydrogens in solution. Okay? An acid is any substance that mixed with water will put hydrogens in solution. And then he says, okay, a base is any substance that will put hydroxides, ions, into solutions. Okay, so now we got our hydroxide ions in solution. So remember, these starts off as compounds, regular chemicals, but when mixed with water, they dissociate, as in they fall apart into their ions, and they take on their charges, like so. Okay, plus charge. They take on their charges. So Arrhenius says acids will put H's or protons in solution, and bases will put hydroxides into solutions. Now, let's go into other stuff about acids and bases, because Arrhenius's definition is actually pretty simple. That's easy to remember, just looking at these two pictures. So I'm going to go ahead and talk about some other stuff concerning acids and bases. Okay, let's talk about strength here. What are strong acids and what are weak acids? Now, let me give you an example. We're going to have hydrochloric acid, for example, HCl. Now, when hydrochloric acid dissociates, it completely dissociates, as in this guy falls apart and you get a bunch of H pluses in solution and his little Cl minuses. The Cl stole the H's electrons, so now we have these little hydrogen protons here. Now, what's actually happening in solution is water is going to grab that H plus. So we have water right here. Remember, water has these two paired unshared electrons, and he's actually going to pull and give these electrons to hydrogen to form another covalent bond, and that we have an H3O plus, and this is what we call hydronium. So we end up with this little hydronium ion, but when we see hydronium or H plus, we kind of use it interchangeably, that's the H proton, but in reality in water, the H proton is going to react with the water to form hydronium. But that's what's really happening. But we still write it like this. HCl gives you H plus Cl. Now, if a compound completely dissociates, right? If it completely dissociates and you get all the H pluses in solution, we're going to call that a strong acid. Now, let me give you another example here. Let's say we took this guy, CHC, put a 3 here, OOH. Now, when I dump this guy in water, we get H plus CH3COO negative. So this is what we get here. Well, here's the crazy part. When this guy dissociates, he does not completely dissociate. Well, he does and he doesn't. What's going to actually happen here, this H plus is going to react again with the guy formed, and we're going to get a reverse reaction here. Okay? So what's happening is we're going to form, these two are going to react to form this guy. This guy's going to break apart to form that guy. It goes back and forth, back and forth. Some of these do go on to form the hydronium ion, the H3O plus, like we said earlier, and that's what makes it a weak acid. Okay, so does not completely dissociate. Okay, and because it does not completely dissociate, it actually goes back to its original substance in a reverse reaction. So we call these guys weak acids. Okay, we call those guys weak acids. So now you have your two types of acids: strong acids, which completely dissociate, and you only get one direction of a reaction, it stays this way. Or you get weak acids to where the products will actually react again to reform the original reagent, and it goes back and forth. And because not all of it completely dissociates, we call that a weak acid. So now, I got to clear up one misconception here, okay? We do not want to confuse, don't confuse with concentration. We do not want to confuse strength with concentration. We just talked about strength. Strength was how much or how does it dissociate. Concentration is actually how many protons are in solution. Okay, those are two different things. How it dissociates and how much is actually in solution are two different things. So when we talk about strong acids and weak acids, strong and weak, okay, when we talk about strong acids and weak acids, we know strong acids completely dissociates, right? So that means we'll end up with a solution that just has a bunch of H's in it, right? It completely dissociates and has a bunch of H's. Well, when we talk about concentration, we would call this guy with a bunch of H's concentrated. But you could also have a solution to where it's a strong acid, it completely dissociates, but there's only a little bit of H's in solution. It has a lot of water in it, right? This is what we would call dilute. So that's with strong acids. But here's the thing. If we put a weak acid in water, I'm going to draw two more. If we put a weak acid in water, we could put a lot of that weak acid in water and still get a bunch of H's in solution. We could still get a bunch of H's. A lot of it's still going back and going back to the original, and overall we wouldn't have as much, dissociating as a strong, but we could still stick a lot of weak base into water and create a concentrated solution. And at the same time, we can have a weak base with a lot of water and only have a few hydrogens and still have a dilute solution. So when we talk about strength of an acid, we're looking at how it dissociates. When we talk about concentration, we're talking about actually how many H's are in solution. So you can have a concentrated strong acid or a concentrated weak acid. Same thing, you can have a dilute strong acid or a dilute weak acid. Remember, when we talk about strength, it only has to do with how it dissociates. Let's talk about bases real quick. Bases. Remember I said, according to Arrhenius, bases put hydroxides into solution. Everything I just said about acids is the exact same as H+. But instead of H+, we're talking about hydroxides. So it all works out to be exactly the same. So if you want to know how bases work, go back and relook at the video, but everywhere I put hydrogen, put hydroxide. It's the same thing. A strong base will dissociate completely. A weak base will only partially dissociate and go back and forth. The exact same thing that happens with acids happens with bases. So when you're talking about bases, it's the same thing. It's the same thing when we talk about strength. How much does it dissociate? How many hydroxides go in solution? When we talk about concentration, how many hydroxides are actually in solution? So just remember, bases are the exact same as acids, but instead of hydrogen, we're using hydroxide. Guys, I hope this helps, and have a great day.